Okay, today we're talking about the intersection of chords theorem, which is one of the rules that goes with circles. So the intersection of chords theorem is very simple. It reads right there on the screen. If two chords intersect in a circle, then the products of their lengths must be equal. Okay. What that means is we've got these two chords in this circle here, and they are intersecting, not necessarily at the center, but they are intersecting. Okay. You'll notice that both of those segments are chords because their endpoints lie on the circle, okay? That makes those chords. Now remember that diameters are chords. So if one of these were a diameter, that would make no difference. It would still work, okay? So what this rule is saying is that where those things cross each other, there's this point of intersection out in the middle that is breaking each chord into two pieces. Okay, and it really probably would be better to put the products of the pieces must be equal. Okay, so when we're looking at this picture here, the red diagonal is broken into two pieces, one that is length A and one that is length B. And the blue diagonal is broken into two pieces, one of which is length C, the other of which is length D. What this rule is stating, okay, is A times B is equal to C times D. It's that simple. We're just taking the pieces of each of these chords and we are multiplying the pieces together. And those pieces, when multiplied together, have to be equal. So A times B has to equal C times D. It is that simple, okay? So this is going to lead us to problems that are fairly simple. They're going to be one-step multiplication problems. On occasion, you might see a problem that has binomials in there instead. Doesn't change how you approach the problem. You do A times B equals C times D. So let's run through some examples here, and then we'll call it a day. So here, we're asked to find the value of X in the figure below. Okay? So again, we have these two chords. We know they're chords because they have endpoints that lie on the circle. So again, I'll refer to this chord as the blue chord, and I'll refer to this chord as the red chord. You'll notice they do intersect each other inside of the circle. That's why this rule applies. Okay? So again, our rule is the pieces of the blue chord are equal, the product of the pieces of the blue chord are equal to the product of the pieces of the red chord, okay? So A times B equals C times D. So we have the pieces of one, no, it should be blue, shouldn't they? The pieces of the blue chord, which we'll refer to as A and B, are 11 and 10. Equal the product of the pieces of the red chord, C times D, X times 55. So we just go in here and we carry out that multiplication. That would be 110 equals 55X. Well, to solve that, all we need to do is divide by 55. And we get X equals 2. Okay, it is that simple. It's not going to be any harder than that anywhere we see it today. Okay, so the product of the pieces must be equal. A times B equals C times D. So grab your screenshot if you want one. We've got 2 more examples to do, and we're going to move to the next one in about 10 seconds. Okay, on to the next one. Okay, again, the picture looks a little bit different, but it is not any different. We still have 2 chords. We know they're chords because their endpoints lie on the circle. Those chords are intersecting, which means that our rule will apply. A times B equals C times D. A and B would be the pieces of one of the chords. It does not matter which chord. So in this case, we'll do 14 times 5. And C times D are the pieces of the other chord. So 7 times X. 14 times 5 equals 7 times X. No, it does not matter. Either chord could be either one. It does not matter which chord is which. One of them is A and B. The other chord is C and D. So we multiply this out, and we have 70 equals 7X. And then we solve that equation by dividing each side by 7, which gives us X equals 10. Okay, X equals 10. One example to go. Please grab your screenshot if you want it. We will continue on to the next problem here. And I believe the next one is our last example. All right, final example for today. Okay, again, this one looks different, and we can't get confused by things that look different, okay? What we've got here is we've got a chord, which we'll use blue for the chord here marked 9 and 9, and then we have a diameter. Well, diameters, their endpoints are still on the circle, so that is still a chord. It does not matter that it passes through the center. That changes absolutely nothing. Okay, all diameters are still chords. So we just set it up same way. A times B, the pieces of one of our chords. Let's say that's 9 times 9. And C times D are the pieces of our other chord, which are X times 27. Multiply that out. 81 equals 27X. And then solve that equation by dividing both sides by 27, and we get our answer, X equals 3. Okay, so don't get what I'm saying here is this rule applies to any two intersecting chords in any circle. It doesn't matter if those chords are diameters. It doesn't matter if they're straight up and down, straight left and right, if they intersect right next to the edge of the circle. What it boils down to is this is always true. A times B is always equal to C times D, where A and B are the pieces of one of those chords, C and D are the pieces of the other chord. Okay? Don't let the pictures confuse you. Just remember that they're intersecting, which is breaking them into two pieces. And the products of those pieces must be equal. Okay? All right, well, that was relatively painless. That is our lesson for today.